So please feel free to add your questions and comments there. We do have a jammed-packed training today, quite a bit of content. So we will be going through this material at a really pretty brisk pace. So it is 12:30 Pacific time. So hello to all of you, wherever you may be, morning, a day, or night. My name is Mark Kim. I am the senior engineer here at Yugabyte. I'm joined here with Seth Lewerson, the director of Yugabyte University, and we're here to present the intro to DBA fundamentals. So just a quick overview of what this course is going to be covering today. At the end of the day, what we're really trying to cover is just show you the different forms and how YugabyteDB is able to be deployed in lots of different platforms. So we'll cover YugabyteDB's architecture and really talk about some of the fundamentals to what database administrators are really looking for in a database system, really checking on the health, just getting help on where and how to deploy it in all the different type of platforms. And of course, we're all going to also talk about a lot of the compatible tools that are available, as well as just places how you can deploy it. So we're going to talk about how to deploy it to the public cloud, to bare metal, and we'll also speak on Kubernetes and a few of the different other API tools that are available for you. So to begin, we're just going to talk a bit about some of the resources that are made available to you from Yugabyte, and this will cover quite a few of the different things that we will be covering today in our course material. Of course, we will be talking about the YugabyteDB itself and how to download our 100% open source software. And then we'll also talk about YugabyteDB Managed. So YugabyteDB Managed is going to be our YugabyteDB as a service product. So basically what you can do with YugabyteDB Managed is really just focus on your business, on your development, and not really need to worry so much about being able to deploy, upgrade, and really maintain your database. So really it gives developers a way to really focus, especially if you're on a smaller team. It really lets you focus on the business aspects and how to grow your business rather than how to manage the database per se. And so, of course, there's lots of different blogs. Of course, there's our GitHub repo that we made available. Once again, this is 100% open source. And then, of course, we have our PG admin tool that helps you connect using a GUI, a graphical interface tool that helps you really have a really granular look at what the database is doing. And of course, we will actually use the Microsoft's Northwind sample database in part of our demos. And then of course, I'd be remiss if I didn't talk about our community Slack channel. So please, if you get a chance, join our community Slack channel, because of all the resources here, that is probably the most valuable resource, because you can go there and ask questions in the YB users channel and also be updated with future training events in our training channel as well. So the course overview for today, we'll be talking a little bit about YugabyteDB. I know if you were there at Seth's training as well as my training, we did cover quite a bit of YugabyteDB's architecture and stuff. So here we will gloss over that just for people that maybe didn't see those other trainings, and we'll really hone in, really try to focus in on how to set it up, how to use YugabyteDB, how to set it up locally, how to set it up using YugabyteDB Managed, how to set it up in other places. And we'll also talk about the different tools and third-party extensions that are available for database administrators. And of course, we'll talk a lot about how to deploy it specifically in the public cloud. We'll also talk about some of the major things that database administrators are really looking for, that is specifically tools to help you for disaster recovery, specifically backup and restore. Excuse me. And then we'll also talk about cluster management. Let's say you need to scale out or scale in your cluster, and just advice and best practices on how to proceed there. First and foremost, let's talk a little bit about YugabyteDB managed. So what I'm going to go ahead and do is kind of show you what our YugabyteDB managed looks like. So just let's talk a little bit about this tool since it is so powerful. So once again, it's YugabyteDB as a service. So you are allowed to use this service to manage, let Yugabyte manage your database system. So why would you use this device? Because it helps automate a lot of these administrative tools such as scaling, tunable backups. You don't have to worry about rolling upgrades for your cluster. It lets you automatically geo-distribute and gives you resiliency right out of the box. And there's just so many tools here that it's a very powerful resource. So just want to let you know that if you are interested, you do get a free account. We used to call it the free tier. I think now we call it a sandbox. So in this sandbox that we offer you, we allow you to have a single node database cluster. So let's go ahead and take a look at this. So as you can see here, you can add a free cluster. So let's go ahead and choose the sandbox cluster type. And then as you can see there, we can just add our cluster name. So I'm just going to call this the demo DBA cluster name. I'm just going to deploy it on AWS. You do have the option to also deploy it on GCP as well. And we're going to use the Oregon US West 2 region. Okay, so let's go ahead. All right, let's go ahead and add our own credentials here. All right. Let's go ahead and download these credentials. Let me go ahead and confirm. There we go. Let's go ahead and download the credentials so we have a local copy in case we do forget what our password and our credentials are. So let's go ahead and create that cluster. So the reason why I did this first is because it does take a little bit of time for the resources to be provisioned. So we're going to go ahead and allow this cluster to initialize, provision, and then configure, and then we'll just come back to this managed service. Like it says, it takes about 5 to 10 minutes for this cluster to be up and running. So let's go ahead and move it back to the slide while this provisions and configures in our background. All right. So first off, we're just going to go through a really quick architectural review of what YugabyteDB does. So first off, I know some of you might have seen this slide before, but this is for people that possibly have not. So YugabyteDB, it's a geo-distributed database for modern enterprises to use as a system of record. Once again, it's 100% open source, very important, because it gives you a lot of transparency into the roadmap of the features and the different aspects of the database that we're working on. By going to the GitHub repo, you can actually see exactly what we're working on. And so YugabyteDB also supports online transactional processing, particularly for mission critical applications. Why it's a great fit there is because it has so much availability and resiliency. So YugabyteDB is also compatible with PostgreSQL and Cassandra APIs. Okay, and so real quick, very important to note, since we are here at Distributed SQL Summit, to know exactly what Distributed SQL actually is and what the requirements are. So a few of the requirements are shown here, 5 to be exact. There's the SQL API, as well as the distributed data store. And not only does the data have to be distributed, but it also needs to be replicated as well. And then, of course, they also offer distributed query execution. And then it's available for distributed ACID transactions, okay? So just a quick look at our architecture here. The query layer of YugabyteDB supports both Cassandra and Postgres. In this presentation, we will be leaning towards more of a PostgreSQL as part of our demos and demonstrations. If you're looking for more demonstrations using Cassandra or our YSQL query layer, please take a look at the YSQL introduction recording that I made earlier this morning. So YugabyteDB also uses the docDB, as you can see on the right, for the distributed document store. So the great thing about that is that it handles the sharding, the load balancing, and gives you that strongly consistent replication without, just right out of the box. So that's what's important there. And then all these factors are super important and actually critical in order to get ACID compliant distributed transactions. DocDB also implements multi-version concurrency control, so MVCC acronym, as you can see on the right there. And basically that's for internal data consistency, okay? So just a quick look. What we're talking about when we talk about that resiliency, and we're talking about being able to withstand node failures, is because it is built with a lot of redundancy, with that replication and that distribution in mind, so that not any single node really contains all the data in your database. You actually have copies depending on your fault tolerance. So the fault tolerance is the maximum number of node failures a cluster can survive while still preserving the correctness of the data. So YugabyteDB replicates the data across all the nodes, so you get this distributed and replicated factor. And basically that helps your cluster maintain your application, giving it zero downtime, even if a node actually fails. So we call this the replication factor, which is the number of copies of your data that are in the cluster. So to achieve fault tolerance for, let's say, a single node, which means I can have a single node fail in my cluster, the cluster has to be configured with an RF of 3. So to survive a failure of one node, you need an RF, which is a replication factor of 3. So data is replicated once again, but what the difference is between here and some other distributed systems is that YugabyteDB is strongly consistent in its replication. Very important. We achieve this using the Raft consensus protocol. And basically, that is a large white paper all in itself. If you're interested in understanding how that algorithm achieves a strong replication, that is a little bit out of the scope of this training for today, but just to let you know, that is the protocol that we use, which is a little bit different than some of the other distributed databases out there. A lot of them use Paxos for the consensus protocol, but we use Raft. It's a little bit simpler to understand. So the number of copies of the data represents the replication factor, and we gave you the equation, how to calculate your fault tolerance, knowing your replication factor, really knowing how many nodes that you think your cluster is able to withstand. So this distributed consensus replication is applied at a per shard level, similar to Google Spanner. So Google Spanner actually does use a Paxos consensus protocol, just so you know. So you need as many machines as the RF of your cluster, just so you know. If you have a replication factor of 3, you need a minimum of 3 nodes or 3 machines in your cluster, just to be clear. So let's talk a little bit about the Yugabyte PostgreSQL query layer enhancements. So basically, the Postgres query layer was enhanced in order to utilize the distributed nature of docDB and YugabyteDB. So basically, we offer you a little bit more, a few more features, including table statistics-based hints. And of course, we also offer network location-based hints as well. So this a lot has to do with the distributed nature of the document store. Then, of course, we had to rewrite the query plan so it actually factors in the fact that nodes are going to be geographically distributed throughout the cluster as well. So we extend PostgreSQL with planned nodes for distributed execution. So here we're just giving a quick comparison of YugabyteDB with Postgres. And of course, Postgres is your single node monolithic traditional relational database. YugabyteDB, on the other hand, is your distributed system, which is why we're here. Why is having a distributed system so much better? Because we both share that SQL API. YugabyteDB actually reuses the PostgreSQL API layer. So that's why you have YugabyteDB, why YugabyteDB is actually known to be the most compatible Postgres API in the current market. But what YugabyteDB has that Postgres doesn't have is, of course, the distributed data store. Incredibly important to be able to automate that sharding right out of the box. And then, of course, we do offer not only asynchronous, but also synchronous replication. And just so you know, once you create your cluster, you will have automated synchronous replication right out of the box. And then, of course, YugabyteDB has this distributed query execution and, of course, distributed ACID transactions, where Postgres does not, because it is, once again, the monolithic single node database system. So that allows YugabyteDB to scale out by adding commodity servers whenever workloads increase. And you can also, of course, scale in if your workload decreases. PostgreSQL, of course, you can only scale up, which is upgrading your VMs and really increasing the capacity of your virtual machine. So here we're just going to talk really briefly about the compatibility of PostgreSQL. So of course, if you have a lot of familiarity with Postgres already, you will really already be familiar with a lot of these commands. So just to let you know, because of the fact, once again, Yugabyte reuse the PostgreSQL API layer. That is why we are able to use a lot of these. There's so much compatibility with the query language. Now at the end, you can see we have extensions, and that just proves how compatible YugabyteDB is with Postgres, because we are able to use those third-party extensions. But of course, there are a few extensions we are not able to use, and that a lot of the time is because it does deal with the distributed document store versus Postgres's storage layer, which are quite different. So that's why some of those compatibilities don't really work right out of the box. But of course, we have gone through great lengths to try and utilize as many of those extensions as possible and reconfigured some of those extensions just so it does work with the distributed document store of YugabyteDB. So going to the next slide, we're going to go ahead and implement a single node. It's not actually a single node. We're just going to implement a local installation of YugabyteDB by downloading from this site. So let me go ahead and show you where that looks like. So here's the download page, and I'm going to go ahead and add that to the chat in case anybody is curious about where to download these things. So once again, in this DBA course, it's going to be important to show how to deploy in lots of different places. So once again, here we're talking about YugabyteDB on a Mac, and you can just simply use this command here to download 2.15, which is the preview version. And just a really quick recap of what these version numbers actually mean. The even numbers is the stable version. Really, it's the GA or general availability of this, that it is stable and ready for commercial use. Whereas we see the 2.15, which is the odd numbers, really is just a preview, like a beta version. We're just rolling out new features, and really it's made for testing and development environments, whereas the stable version is really more for production environments. We will be using 2.15 today, so let's go ahead and download. But before we get to that, let's go ahead and take a look at some of these different ways to install. So of course you can use simply copy and paste this for Mac OS, but there's also copy and paste for Linux. And then of course there's the Kubernetes. We can use the Minikube and the Helm charts to actually download from the Helm chart. And then of course Docker installation is used, especially if you have Windows. Sometimes this is the best way to download locally for Windows OS. Then here we're going to talk a little bit about multi-node clusters. And really we're talking about the public cloud. So here we have AWS, which is we're using this CloudFormation API. We can also use this form to create our Terraform file. And then of course the EKS is used here for our Kubernetes installation as well. And then of course we did talk about our fully managed cloud, which we did sign up for. Speaking of that cloud, let's go ahead and do the install first, and then we'll go ahead and double check and see if that cloud YugabyteDB managed service is ready. So what I'm going to do is just go ahead and do a copy there, and then go to my local machine. Here we go. And see, I created a demo file here, and I'm just going to go ahead and paste that information there. As you can see, it is actually fetching and uncompressing that file, as you can see there, and bingo, just like that, it's already available. So what I'd really like to do is show you what the bin folder looks like. These are a lot of tools that are available with the installation of Yugabyte. So once again, we used 2.15. As you can see here, some of the big CLI tools that we'll be using today will include the YSQL shell, which is here. Sorry, I used that one earlier for my SQL demonstration. So we will be using the YSQL shell, and this gives us an ability to use a CLI to actually connect to our database, as you will soon see. There's also this YugabyteD, which will help you quick spin up a single node cluster. And then we also have, of course, YBCTL, Yugabyte control. So we'll actually be using that in order to spin up a 3-node cluster locally. I believe Seth actually used YBCTL in the Gitpod hands-on lab demonstration in the previous training. And then, of course, we have our other commands like ybdump. YBadmin is actually quite useful for scaling out and scaling in and doing a lot of configuration for the cluster, just to be sure. All right, so let's go ahead and take a look. I think the next step should be just to spin up a cluster. So we're going to use the YBCTL, and we're going to go ahead. But actually, before I do that, I do need to do a quick check to ensure that I have my loop back IP addresses available. So let's go ahead and do a ifconfig. As you can see, they are available here. So these loopback IPs are necessary to keep them open so that when we spin up our cluster, the nodes have an open IP address. So we're just simulating what a node will look like in our local machine. So that is why we need those loopback addresses to simulate the different nodes in the cluster. So now that we do have that, let's go ahead and spin up our first cluster. So we're going to go ahead and use that bin folder and use YBCTL. We're going to go ahead and use a RF, a replication factor of 3 that gives us a 3-node cluster. We're going to go ahead and hit that create command. All right, so it looks like I have something there already. So let's go ahead and check the status. It looks like I have something there already. So I'm going to go ahead and stop this cluster. So in case you know how to terminate a cluster, this is how you do it. First, you do the stop, and then you do the destroy command to get rid of all the data files. So now that we destroyed the cluster, we can actually go and check the status and see that no cluster data was found. So now we are actually able to spin up our cluster by using the same command as we did previously. And so now we're just waiting for the cluster to be ready. And then soon enough, it will actually spin the cluster up. And once the cluster is spun up, as you can see, so there you go. So here we see a cluster is ready. We have a node, 3-node cluster. That is our topology with a replication factor of 3. So the replication factor is equal to the minimum number of nodes that is necessary for a cluster. Of course, you can have more nodes than the replication factor, but at minimum, you must have at least 3. And here we can see that we do have few of our CLI commands available for us. We have the YSQL shell, we have the YCQL shell, and of course here's the web UI, which is quite interesting. And this kind of gives us access to what it gives us information on how to monitor and look at our database. Let's go ahead and take a look there and see what that looks like. So here is the web UI that's connected to our local machine. As you can see, it gives us the universe ID, lets us know the replication factors, and of course you can also look at the different tablets. Now currently we don't have any user tablets because we just spun up this cluster. So rather than that, let's go ahead and use the cluster and load up some data. So let's go ahead and take a look at the YSQL shell. Once again, this is the CLI command to connect to your database. So I'm going to go ahead and clear out to give us a little bit more room so we can actually take a look and see what databases are currently here. As you can see, these are all the system databases that come with the cluster right out of the box with the download. So what we would actually like to do is create our own database, and we're going to call this Northwind Local. All right. So once we create that database, we're going to need to connect to that database as well. All right. There you go. So now we are connected to the Northwind local database. And if we look at the table relations, of course, we don't find any. So let's change that and see if we can actually add some tables to this local instance. So what we're going to do here, all right, so we're going to go ahead and add this Northwind database. And just as a quick note, just so everybody's aware, Northwind is actually a sample database that was originally created by Microsoft back in the 80s. And it's really been the basis of a lot of their tutorials. So what Northwind database actually is, it's actually sales data for a fictitious company called Northwind Traders. And just to give you some context, basically the idea is that it imports and exports specialty foods from around the world. It's an excellent tutorial schema for a small business ERP. Here's a look at what all these 14 tables looks like. And of course, with all these tables, there are quite a few rows of data. I'm thinking thousands and thousands of rows that are available here for us just for demonstration purposes. And if you're interested in actually looking at what the scripts look like, this is what I have copied and downloaded to my local machine so that I am able to load this. So what I'm actually doing is a restore, where I'm actually restoring this database from this script file. So let's go ahead and add that. As you can see, we are indeed running the script, and in that course, it is actually creating all 14 tables for me. So once this table is finished creating the tables, so we created this locally. So once it's done there, we'll go ahead and insert the data from the file as well. So we're going to actually use the DML file here. And as you can see, it's inserting every single row. And once again, these are thousands of rows. So let's take a look while we have the chance of looking at our local machine here through the web UI portal. Just look at what's happening here. And as you can see, just verifying and validating that our tables were indeed created. Excellent there. And then we can actually go to the tablet servers. We can see that the tablet servers are alive and healthy, and we can see that there are operations happening on these nodes. Very good. So we can actually look at each server individually as well and look at the different operations that are actually occurring there. So taking a look back at the tables and the tablets, you can actually see that the 12002 is actually the leader of the three. Okay. So just to verify that we indeed do have our inserts happening here. And here are a lot of the log files as well. So just gave us a good idea and a look at what's happening there. And of course, it is still writing because we do have so many rows of data. So we're going to go ahead and open SQL shell here. Probably need to look at that. All right, and then we can look at SQL shell, and then we're going to need to connect to the Northwind local database. And the reason I'm doing this is just so you can actually see that I am connected to the database, and from here I can actually take a look at the relations as well. So here's another way to validate that the Northwind sample database was indeed restored back to our local database. And of course, you can just use your basic commands from which table. Let's just pick region, and then you could see the result set happening there. So this gives us a really great opportunity to play around with this sample database. Okay, so let's go ahead and finish that demonstration off and try to get back to the presentation. So we did do a local install. We actually spun up a 3-node cluster. And then, of course, we took a look at the UI and showed you what the users tables looks like. This also installed Northwind as well. And then showed you, of course, what the YSQL shell looks like and how to connect to the new database that was connected there. And then, of course, we showed you this is the basic restore command. So we actually were able to restore the database from the Northwind. Okay. I'm just checking the chat to see if there's any questions here. Will you be showing how to start a YugabyteDB configuration file, say YBT server flag? And will this YBT server flag be set for subsequent nodes? I would add. Currently, we are not actually going to be doing that as part of our demonstration, but if you actually connect with me in the community Slack channel, I could probably help you a little bit further with your particular question. So can Yugabyte be spun up in multiple clouds? That is absolutely true. We can have multiple clouds, multiple regions, multiple zones. The greatest thing about YugabyteDB is the flexibility that you actually have with it. And why would a company or an enterprise want multiple clouds? Let's say still using our e-commerce example, that it's Black Friday and that you are expecting a lot of pieces in your workload, in your operations per second because of the spike in your workload. I would love to buy more commodity servers. Let's say I'm on GCP, but for whatever reason, because everybody has the same idea, there are not any commodity servers, the ones that I need in particular, available for me. So having a multi-cloud solution allows you to actually shop around for not only better availability, but also better prices, because currently, sure, some of the prices remain somewhat similar, but let's say there's a spike in demand and the supply runs low. We all know what happens in that case. The price increases. So the multi-cloud solution really allows you to shift your workload to whatever cloud provider you actually want. Okay, hopefully that answered your question. So will data be strongly consistent across the cluster and not eventually consistent? Excellent question there. YugabyteDB is proud of the fact that it was built with that data consistency in mind, that data integrity, to keep it ACID compliant for your OLTP, online transactional processing, for mission critical data. So absolutely 100%, it is strongly consistent. You will not get that with some of your other distributed systems. I think like Cassandra and Mongo might be more eventually consistent, where they eventually sync their data, but YugabyteDB is guaranteed to be strongly consistent, okay? Okay, so let's go ahead and go to our next demonstration, where we will be talking about our DBA tools. So when we talk about DBA tools, really we're talking about third-party extensions that were created due to the fact that Postgres has been around since the 80s. We're talking about a very mature ecosystem. With that mature ecosystem, we've had thousands and thousands of Postgres developers, and for those developers, there's been tools that have been created to help them facilitate their development workflow. So here are some of the tools that are available with PostgreSQL. So we're talking about historic GraphQL with workbenches. So a lot of these tools are GUIs to really help you look at what's happening with your database. And of course, there's lots of other tools here as well, like Prometheus and Grafana, to really give you a granular look at monitoring services as well. So in general, if the tool is supported by PostgreSQL, it will be supported by YugabyteDB in general. So here we're going to talk a little bit about pgadmin and how it's used. So this is a GUI, and as you can see, it really shows you a lot of the granular information of your database. So let's go into go into our second demo here. And in this case, what we're actually going to do is check up on our managed service to see if our cluster is ready. So as you can see, the cluster is now ready to be used. All right, let's go ahead and get rid of that. First and foremost, as a reminder here, you cannot connect yet. This cluster doesn't have any IPs that are allowed. So you cannot connect to the shell or the application or anything. So let's go ahead and add that IP allow list. So let's create a new list. We're just going to call this list local, because it's just going to allow my local machine to connect to this cluster. So we're going to go ahead and just detect my IP and just save that there. As you can see, adding the cluster allow list now, it takes about a minute. And the great thing about our services is that it's speeding up all the time. Our engineers are hard at work, really improving our services here. So as you can see, the local has been added to this cluster in, remember where this thing is deployed. This thing is deployed as YugabyteDB managed. And once again, I'm getting this brand new free cluster that's deployed on AWS. But the fact of the matter is, I didn't have to touch an ounce of infrastructure. I didn't have to provision anything. I don't have to worry about the VPC and different IPs and making sure different ports are open. That's the ease of use of YugabyteDB managed. And maybe eventually everyone will only be using YugabyteDB managed because it just works right out of the box. And right away, I have a database, it's already deployed, and I can already connect my application to it and have something that everybody in the world can see in a matter of minutes. So let's go ahead and take a look at our network access. And we're going to go ahead and look at our cluster here. Once again, it's demo DBA. It's deployed on AWS using a single node. And then what I really like to do is connect to this cluster using their host name. So what I do is I click on the cluster and go down to the host name and just copy that host name. Very important. And once again, it's important to note that we are actually using YSQL port 5433. Very important to note. And then what I'm going to actually do is go back to our PG admin and use this third-party tool to actually connect to my cluster that's in YugabyteDB managed. So let's go ahead and add that server. So what I'm going to say here is this is going to be Northwind YB managed. The name of that server. And then for my connection, I'm going to add that host name that I just copied there. Then, of course, the port is actually going to be 5433. And you may be familiar with 5432 because that's the one that Postgres actually uses. But we actually use 5433. And we're going to actually say we're going to use the Yugabyte database for the maintenance database. And then we're going to use the credentials I use to log in to my YugabyteDB managed cluster. All right, so hopefully I spelled that correctly. I'm going to go ahead and see. No, I did not spell it. So let's try that again. All right, there you go. That seemed a little better. So, all right, connect. Interesting. All right. My admin tool. I see what I did. Okay. So looks like I have some kind of connection problem there. So not to worry. I probably have my caps locks on or something silly. Let me check here. Okay. Interesting. So let's go ahead and advance this conversation. You know what? Instead of adding locally, I can always also just connect to my local instance as well. So I'm going to go ahead and connect to my Northwind. Let me see. Northwind_local. And the username here is going to actually be Yugabyte. And password is also going to be Yugabyte. So let's see if this gives us any more luck there. Okay. Host. There we go. Connection. There we go. So just connected to my local instances. As you can see, since I already connected my Northwind database there, you can actually see that it has connected. So let's take a look at my databases. Once again, it's Northwind local as my local connection. And then if I go to my schemas, I'm actually able to look at the tables that were connected there. So here we go. So here are the 14 tables that I actually restored from my SQL script earlier. If you go to something like regions, for instance, we can actually see all the different columns, region IDs. It gives us an idea of what the indexes look like. So you can see why this type of GUI tool is so powerful, because it gives you so much granularity, so much information about what's happening with your table. So we can actually go to the shippers and really look at all the materialized views and indexes and rules, and just especially for really large and complicated database systems. This kind of tool is actually quite useful. So let's go ahead and take a look at the database connection tool. And so we can actually look here, okay? Then we can actually be connected here, select star from region. All right. Actually execute that command. And you can see here that we were able to look at what data is inside our region table. We actually use some tool like explain and analyze. It'll actually give us a nice little query plan and tells us that we actually used a sequential scan, obviously, since I did select star and looked at accessed every single row. It gives us how many rows we looked at, how many loops it actually took. A lot of these loops, sometimes we'll be looking at different joins and foreign key restraints to see how many different tables were looked at as well. So just an idea. It also gives you the analysis part and gives you the time of how much the analysis of the time that was necessary to complete that query. Okay, so just a brief look at PG admin tool. Of course, dbeaver is quite similar to this as well. The cool thing about dbeaver is that you can actually use it not just for Postgres compatible databases, but you can actually use for all different sorts of databases, including MySQL and Oracle databases as well. Very good. So now let's go ahead and move on to the rest of our presentation. And we'll really look here today at some of the deployment platforms and how we can deploy things to different places. Of course, we're going to talk about bare metal, which is on-premises type of installations. There's also Kubernetes. And then we'll also talk about different virtual machines, I believe. And then, of course, we'll talk a bit more about public clouds, which is a very popular option because obviously the cloud computing is such a huge part of enterprise solutions. So we will be talking about the different public clouds that are available. Specifically, we'll dive deeper into AWS and GCP. So here's just a quick checklist and just an idea of what we're talking about when we're trying to deploy YugabyteDB cluster. This SSL certificate is missing. Thank you. I appreciate that. Here we go. So for the YugabyteDB cluster, it consists of two distributed services. So the YB master as well as the YBT server. So those are the two services that are located on every single node in your deployment. So the YB master actually is responsible for the metadata as well as the cluster-wide operations. And the YBT server is actually responsible for the data and the I/O as well. So when we talk about input and output, really the YBT server is really handling what we're talking about, reads and writes and inserts and searches. So the YBT server must be on every single node of your cluster, whereas the YB master service is only going to be equal to the number equal to your replication factor. So really it has a lot to do with your fault tolerance of your cluster. It tells you how many YB master services are on every node. So not necessarily is there going to be a YB master on every single node, but there will be a YBT server on every node because it is the process that's necessary for data and input and outputting. Okay, so just to note, YB master is the one that really brings up YB master first. Reason being is because YB master really handles the table-wide cluster, table-wide level operations, and it is knowledgeable of the system catalog. So it really knows pretty much where all the data is in the entire cluster, whereas YBT server doesn't have that kind of cluster awareness. Next, we'll talk about the replication. So the number of YB master servers must match the replication factor. So we'll run each server on a separate machine to prevent losing availability on the servers. And then, of course, the replication factor is equal to the number of YB master servers as well. And the number of YBT servers actually equals the number of nodes. All right. So here are some of the basics for production workloads. And we have a best practices recommendation for operating systems. We really like what I've been using more than anything else is actually CentOS 7.x. There's also the RHEL 7.x as a possibility too. So once again, these are these Linux flavors. CentOS for AWS, for instance, is only available in the marketplace for a fee, just to let you know. And then there's the system limits using ulimit on each node using a YugabyteDB as a server. Then, of course, there's the NTP or cronny to synchronize the time. So there we're really talking about the ability to have concurrent operations and how do they really sync, whether it's like serializable locking or of the such, ensures that we don't have a lot of conflicts and we really know which operation to operate first in this concurrency for these large distributed systems. So you can just imagine, once again, when I'm giving these examples, we're talking about really enterprise level database solutions. So we're talking about maybe hundreds, if not thousands, if not more operations per second. So how do we isolate? How do we synchronize the time? How do we make sure that it's locking correctly so that all the operations are occurring and each one will be successful? So we have that idea of atomicity to make sure that the transaction either completely succeeds or doesn't work at all. Here we're talking a little bit more about the checklist for the hardware that's available for your CPU. So a minimum, we're talking about 4 cores, but really when we're talking about production, we're really talking we need something a bit larger, something closer to 16 cores. So of course, YugabyteDB performance improves with the more CPU that's in the system. Without enough CPU, just expect a lot higher latencies and dropped requests as well. So here are some of the hardware requirements specific to the memory. So real quick, here's a question. Do you recommend to use Ubuntu for production workloads? So in this case, yes, Ubuntu has been used in the past, to my knowledge, but CentOS and RHEL are really just best practices just because it has been shown to be the most reliable. And really, when you're talking about a database system, really looking at something that's going to be incredibly reliable and also resistant and error prone and bug prone. So once again, some of the minimum specs for the hardware, we're looking at 4 gigs of RAM, and then for production specs, 32 gigs RAM. And then typically when you're writing, it requires typically about 4 gigs of memory if you're doing something that's very write heavy. So yes, it really depends on what type of workload, what type of application that you're using YugabyteDB for. And then of course, we do not only recommend, but we require solid state disks. So obviously we're talking about trying to have a system that is highly performant at web scale, at petabytes of data, huge workload. So in order to really achieve that type of linear scalability, that type of high performance at that web scale, we do need to have really good hardware requirements. So SSD is part of the requirements as well. Do not use RAID across multiple disks, as YugabyteDB natively handles multi-disk nodes. And then, of course, there's XFS as the recommended file system. And then best practices are to use NOAA time setting when mounting the data drives. Okay, so with heavy applications, if the data doesn't fit in the cache and the data needs to be read from disk performance will start to matter. So just a couple things that should be top of mind when deploying YugabyteDB on any platform. So of course here there's network requirements as well. So we're talking about the different ports that need to be available. There's a lot of communication going on to make sure that we have data integrity, to make sure that we do have that strongly consistent replication that is key to having an ACID compliant transactional database. So there's a lot of remote calls happening between the nodes to make sure that all the nodes are healthy and responding. So we're talking about port 7100 and 9100 for the communication between the master and the servers, as well as port 7000 for the master admin UI, and then of course 5433 for YSQL for the Postgres API, and 9042 for the YCQL or the Cassandra compatible API. Next, we're going to talk more about different public cloud deployments. So we'll start this conversation looking at AWS. So really we use the C5 or i3 instance families, and then of course it really depends on your workload and what you're using it for, but our recommendations, especially for productions, are going to be to use the X large, the i3.2x large. Of course, these are a little bit more expensive, but in order to get that performance at scale, we do recommend to use some of these larger instance types like C5 4x large. And then, of course, we actually recommend using the GP2 EBS for the solid state disks to ensure that you have at least 250 gigs in size or larger as your workload requires. And then, of course, we recommend not using things like the T2 or some of the really smaller instance types, because you will find that there is an incredible lag and latency, and you just don't want YugabyteDB to be called out at fault for those type of latencies. Then, of course, we are talking about how to install using CloudFormation. So you need an IAM user with certain privileges. Specifically, you need AWS CloudFormation full access, the EC2 full access as well, and the SSM to get the parameters. And this way, you can actually use CloudFormation to actually spin up your cluster. If you're going to create the stack using the AWS console, make sure the user has accessibility with the S3 bucket as well. And then here you're going to see an example of what the CloudFormation YAML file will look like. First, here's all the different parameters and properties and how they need to be defined. Of course, you can always take a look at our Yugabyte CloudFormation YAML file that's located on our GitHub repo if you would like to get a copy of that. And then here we're actually letting you know how to actually use that YAML file in order to create and deploy and provision our YugabyteDB instance. Here we're going to talk a little bit more about GCP, specifically what type of instances are needed for Google Cloud. Here we're talking about the N1 high CPU instance family, or as a second choice, N1 standard is also recommended as well. And then other recommended instance types will include the N1 high CPU 8 and the N1 high CPU 16. Of course, these are a little bit more higher performance instance types. And this is just to ensure that at web scale, the server is able to compute and perform well at large workloads. So locally, we're talking about SSDs, of course, solid state disks for the storage options. And then we're talking about very similar types of parameters for storage. Here, we're talking about 375 gigs in size. And then as a second choice, remote persistent solid state disks work as well. All right, so avoid running on F1 or G1 machine families, okay? So here we're going to talk about how to deploy using GCP. And in this case, we're actually using, we're actually connecting to our GCP instance, and we're going to go ahead and update Linux, install the Git tool, clone GCP deployment manager, and then once you change directories into that folder, we're going to actually use the deployment manager to create the deployment using that YAML file. So using the GCP deployment manager goes as follows. Pretty much you're going to create the deployments here and use the fingerprint of the deployment. And then it will be able to create the operation. You can see the result set here of the response you get from GCP for a successful deployment. And once again, you can see all the information regarding how to look at the UI or the Java database connection tool, as well as how to connect to your SQL shell or your YSQL shell. And then once again, we're going to go ahead and just use this Google Cloud Deployment Manager to describe the deployments. So you can take a look and use the YugabyteDB admin URL to access the web admin portal. So here we go. We're talking more about the deployment manager and how to describe. This is an actual instance of describing the deployment here. So you can see what a successful deployment result set looks like. Next, we're going to talk a little bit more about disaster recovery. So this is obviously something that all DBAs really need to know about, because we're talking about how to back up as well as how to utilize the point-in-time recovery. So here are some of the CLI tools that are available to you. I did show you some of these tools previously that are located in that bin folder for our local on our local install. So we have our YSQL dump. Basically, this backs up a single database. We have the YSQL dump all backs up all the database. Of course, we already used the YSQL shell. We're going to use that using the \i to restore the database. And of course, we also have the YSQL-admin tool that will give you a snapshot of the database for our point-in-time recovery. So backup using here, we're going to use these tools here. So obviously we talked a bit about using that bin folder in the Postgres bin folder there. So we can back up a database using these files. So here we have an instance of how to use YSQL dump. Of course, you need to specify the database. And then of course, let them know where you would like that database to be located. Here we have an example of backing it up to our local machine. And then once you've backed it up, we can use that \i command that we actually showed previously with the Northwind sample application. And we can actually use that with the YSQL shell, like I did previously, and you can actually restore that. So we actually did a restore of the Northwind sample database previously to our local machine. You can also use the -f command as well. So otherwise, the -f option is entirely equivalent to the meta command, okay? So here we're going to talk a little bit more about creating a snapshot. So snapshots and backups are quite different. Snapshots actually create like a linked list, so it's like a virtual snapshot. That's why it's much faster to perform, and basically why you can actually take a snapshot and schedule it on the hour, which is quite different than on a backup in itself. So a snapshot really utilizes that linked list kind of data structure to really help create that virtual system. So we're not utilizing so much storage space in order to constantly back up our databases. So the cool thing about the snapshot, even if you have it scheduled on the hour, you can actually use the snapshot with YugabyteDB to give you like that fine granularity if you need to restore your database to a particular time before a particular option took place. Maybe you experienced this particular query that corrupted data for whatever reason. You can use that snapshot to actually revert to a previous version prior to that operation. Even though the snapshots are only created on the hour, you actually get a lot more finer granularity to actually restore to a specific time and place. Once again, point in time recovery means that you can actually choose the time that you actually restore to. So here we're going to actually give an example of how to take a snapshot with the YugabyteDB CLI tool. So here we have a current YSQL schema, catalog version is the name of it. And then what we're going to actually use is the YugabyteDB tool with the master addresses. So basically these are the addresses of your nodes, and it's actually going to create a database snapshot. And then once the snapshot is created, we can actually list the snapshots that are available. Once we've created that snapshot and verified that the snapshot is correct, we can actually create a backup of the YSQL metadata using the YSQL dump command. Here we're talking about how to export the snapshot using YugabyteDB. So we can actually get the current YSQL schema catalog version here. And then we can actually create a snapshot metadata file, and then we'll copy it using the next command, using the metadata dump command. And then basically and then it'll copy the tablet snapshots to the directory with the CP command here. So here we're going to actually import a snapshot using the YugabyteDB tool. So here we're going to import YSQL metadata and then import the snapshot metadata as well. Okay. And then of course we have the restore tool. With every backup, you also need to have an ability to restore from the snapshot. So here, using the YugabyteDB CLI tool, we're actually going to restore that snapshot using that snapshot ID with the restore_snapshot command. Very straightforward. Once you list your snapshots, it will give you all the snapshot IDs, and it'll give you actually the state of the snapshot as well. So here we have a point-in-time recovery, creating a snapshot here. So it's a little slightly different here. We're using, once again, the YugabyteDB tool to create these snapshots and then list the snapshots there. And then with the point-in-time recovery, we can actually restore from absolute time. So here we're actually going to retrieve and get a timestamp. And then we're able to list the snapshots in the example on the right. And then we'll be able to restore the latest snapshot to the timestamp you obtained before you made the data changes or that bad operation that you're trying to actually revert to. So in order to verify the restored state, make sure that it doesn't include the data changes. Okay, so verify that the restored state does not include data changes in your restored snapshot. Here we have point-in-time recovery, restoring from a relative time. For example, it tells us that we want to restore 5 minutes ago. And so here's some of the code. 5 minutes is 5M, 1 hour ago is 1H, 3 days ago, or 1 hour and 5 minutes. So it gives you a lot of granularity to just restore from. So it lets you restore to the time you want. That way you won't lose valuable data that was in the system, but it lets you also avoid any corrupt operations that you're trying to avoid. So here we have an example of how to actually restore a snapshot from a specific time. So let's say we have scheduled snapshots to happen on the hour, every hour, then you can actually use relative time to restore to a time before that snapshot took place, before the data operation you're trying to avoid took place. So that gives you a lot of flexibility using relative time to restore your snapshots. Now we're going to talk a little bit more about cluster management. So basically, as a database administrator, some of the tasks and duties that we're going to be responsible for is really maintaining the cluster at peak performance, making sure that the nodes are healthy and they're not overly stressed with large workloads, to make sure that the cluster is load balanced, to ensure that every node has a similar workload as everything else, just to make sure that we don't get like a hot node or a hot partition that will slow down our application. It could actually lose queries if the clusters are not maintained properly. So it's important that cluster management is in the tool belt for any database administrator. So we're going to talk here about how to configure rolling updates. So obviously any database, any software system needs to have updates to the software for security improvements, for new features. There's a lot of, like I said, if you look at our GitHub repo, we'll show you all the different features and security additions that we're adding to make YugabyteDB more robust and more reliable, especially for enterprise solutions. We'll also talk a lot about how to scale out as well as data migration. So when I say scaling out, we're also talking about how to scale in, scale out using these commodity servers to really manage your cluster relative to whatever workload you have. So just that flexibility, okay? So first and foremost, we're going to talk first about the cluster configuration. We're talking about how to maintain uptime for your application. Even though you're doing a cluster configuration, you can do this by really creating another cluster and moving the configuration so that your YugabyteDB cluster isn't down and isn't really processing the workload, because you are able to actually create like a redundant cluster that's able to handle the application while your original cluster is updating to the new configuration or to, let's say, a version update. See here, the configuration, this is the topology we have here is a 6-node cluster. Obviously, you can tell because we have 6 nodes, but the replication factor here is actually 3. And you can realize that because only node 1, 2, 3 actually have that master server located there. So you know that we have a fault tolerance in this cluster of 1, which means one node can go down and maintain application uptime. So SQL admin is going to be the CLI tool that's really going to help you with these configuration changes. So what SQL admin does, so here's just some of the commands that are available. We can do the change blacklist. So basically it tells us what old servers need to be terminated, and this enables you to really get rid of any nodes that you don't want. So this is a kind of a fine-tuned way to change the configuration of your cluster by using the blacklist. And you can also get the universe configuration as well, just describing what the schema or the configuration of your universe looks like. You can also use the get load move completion. It really checks how much the percentage completion of the data. And you can also use the change master config, changes which masters are on which nodes, also allows you to change, let's say, the replication factor, and then you can just list all the masters and will give you all the information. So really, it's just a tool to really inform you and let you know exactly what's happening with your universe. So here we're going to step you through how to provision and start new nodes. So we're talking really here about our scaling out circumstance. So why will we scale out? Because our workloads have increased, our nodes CPU usage has gone up a lot, and we need to provide our cluster with more CPUs to manage the workloads. So here we're going to provision some new machines. I'm going to start with the YB master servers on nodes 7, 8, and 9. So first we're starting once we create a new cluster, we always start with the YB master server first because it has that cluster awareness, it has that table, has all the metadata, has the information for the system catalog as well, where all the information lies. So you always start with the YB master service because you need to begin your master quorum. And then of course you will start the YBT servers on all the nodes in the cluster. So that's nodes 7 through 12. That's all 6 nodes in that replicated cluster. Okay, and then next step, you can actually blacklist the old tablet servers before moving to the new nodes. That way, all the workloads from that old cluster will actually be shifted to the new cluster. So that's just giving you like a step-by-step flow process of how you actually do that configuration change. You create the new cluster and then you blacklist the old cluster, and that allows the Raft consensus algorithm to distribute the table data to the new, supposedly newly configured cluster. So here we're going to talk about how to check the progress of the data. Once again, we're looking at the get, load, move, completion, and it kind of tells you, it gives you an update. It's very nice of exactly how much of this configuration change has been completed. Of course, when we're talking about enterprise solutions that have possibly hundreds and hundreds of nodes, this process can take quite a while. So it's nice to get some kind of update to see exactly how much more time it's going to take. And then, of course, step 4, we'll be looking at how to update the T servers once the master servers, the YB master servers have been completed. So then first what we do is we actually set up the T servers on all the nodes. So once again, we're talking about nodes 7 through 12. And then we're going to be able to change the blacklist. And then we'll be able to actually terminate the old nodes. So obviously the old cluster is something that we don't need anymore. That's obviously extra provisioning costs that we don't need to absorb since we do have our newly configured cluster. And then just to ensure, we can look at the master addresses to get some kind of transparency to see exactly where the masters exist to ensure that all the old nodes have been terminated. So here we're talking about some best practices when we're talking about version upgrades or configuration changes. When we're upgrading YB master or YBT server, we always do it one at a time and use the web admin UI after each step just to verify that every cluster is healthy. And then when scripting the upgrade, pause 60 seconds before moving from one process to another. So obviously this is not a process you really want to rush. You got to really take your time and to ensure that every node is spinning up the way you expect. And then of course you have the data, log, and conf directories that are generally supported in a separate location, which stays the same across the upgrade. So here we're going to show you how to upgrade a cluster. This is talking about versioning upgrades for your universe. So number one, you want to go ahead and install the new version and then upgrade the YB master servers using it. So here what they did was they actually downloaded Yugabyte with that tar and then untarred it and then went inside to do the post install shell command. As you can see here, first they killed the YB master processes, then just made sure that the directory of the new version was available, and then they upgraded the T servers as well. Here we're going to talk more about horizontal scaling. So what is horizontal scaling? Like I mentioned previously, this is our scale out option. So basically it just adds more nodes, it adds more YBT servers to your cluster. Horizontal scaling does not add the YB master servers though, because that would actually add more replication and add more copies of your data. What adding more nodes or adding more T servers does, it doesn't actually add more copies of the data. It actually just provides more CPU to process the data. Okay, so you would probably do this because you needed more CPU to handle all the input and output responses. Basically, your I/O operations have increased, your workloads increased, so you need more CPU to handle that increase in workload. So the number of nodes in the cluster running the YBT servers must be equal or exceed the RF. So we talked about that previously. So start YBT servers with the command line flag. So here on the right side, we actually are looking at the YBT server CLI. So we're actually looking at that too. And look, you can see there's quite a few command line flags that are attached. You can always see the command line flags. I know it looks like there's a dash space dash, but in actuality, it's actually just dash with the space, just so you know. So here we have, actually, I think it's just dash and then the command. So here we have, basically this tells us where the placement of these nodes are going to be. And then of course we have our YBT servers and all the different command lines. And this just gives you that fine-grained flexibility and the ability to actually place different nodes in different regions. So if you want that geographical distributed model, YugabyteDB does an excellent job in letting you place your nodes where you want them to be. And this really gives you that resiliency. So let's say we have a power outage in Texas or anywhere really. So those data centers go down. This gives you the ability to actually place the nodes in different data centers geographically dispersed so that the power outages in certain regions doesn't affect the uptime of your application. So remember, the rebalancing of the workloads actually happens automatically using that Raft consensus algorithm, as well as your sharding strategy. So here we're going to talk a little bit more about the migrations. Obviously, migrations is quite a very large subject, especially when you're talking about some of the advanced modern type of enterprise solutions that are out there. Migrations can get quite complex, but in this case, we're just going to talk about the basics for today. So be sure, Migrate DDL is compatible with YugabyteDB. And then we're also talking about not only migrating the DDL scripts, but actually the DML scripts as well. So basically you can export the data from the source, for example, PostgreSQL, and then you're able to prepare the cluster for import of these resources. And then you're able to import the data and then finalize your data definition language and then verify your migration. So these are the basic steps of how we're going to do the migration. You always start with the DDL, then you go to the DML, and then you export the data from the source, and then you import the data to your final destination, wherever that may be. So first up, we're going to talk about here is how to import the data. Here we're using the -f command. We can also use the copy command from CSV files, or actually do it programmatically. And the file should have been generated using pgdump or the YSQL dump commands. Okay, so those files, we're talking about creating the backups of the databases. So that's when you're talking about files, we're talking about the SQL scripts. And then we can use the YSQL shell that we did previously using the \I command to actually restore or execute the import. So we call it here as importing the database and importing the table. So as you can see here. So that brings us to the end of our presentation for today. So just wanted to really emphasize that you are available, you are eligible actually to actually use the DBA. You are automatically enrolled into the YugabyteDB DBA Fundamentals exam once you have completed this course. So I just want to give a quick demonstration of what it looks like to finish the course, as we say. So let's go ahead and take a look. So this, once again, is the, oops, sorry, here you go. So this is the course that we went over today. I'm going to go ahead and add this to the chat. So here's a couple questions here. How do you roll back an upgrade? So rolling back an upgrade is actually a complex type of situation. I'm going to go ahead and leave that conversation a little bit beyond the scope, but rolling back version upgrades is actually, I'm not sure if it's actually supported up at this time. So I know there was a lot of discussion within the company whether we should be able to do that or not. So at this point in time, I cannot tell you that it is actually possible to do that actually. So real quick, going back to the course, here is the course player. In order to show that you have 100% completed this course, you will have to go through each of these sections and then of course click the next attribute, which is set here. Whoops, I'm actually on the wrong one. Here we go. So this is where I wanted to go. So this is the course player that you see. And of course here, you're going to find the next button. So once you go through the next button, I'm going to just show you how to do one like that. And go through the next slides. You can actually show that you have completed each section. So you can go through each of these slides and then hit the next button, and then it will actually show that you have actually completed this section as shown there. And then you can see the breadcrumbs or the completion rate does increase. You will need to complete this course at 100% in order to be enrolled into the exam course. Why would you want the exam course? Why do I want a test? The whole point of that test is actually to receive your YugabyteDB DBA certification. So having a certification like that, it's just a cool, like a nice little kudos, as well as just the ability to maybe post it on LinkedIn and just show people that you are interested and you are diligent about learning about distributed SQL. Why is distributed SQL so important? Because it is actually the next step in the evolution of the database, showing people that you are on top of cutting edge technology is actually something that is a worthy tool and something that you want to show people, because it shows that you are constantly improving yourself and your abilities as a developer. Real quick, just want to note that here we go. Note that the but the recording of this presentation will be available in the course player as well. So just to let you know that if you would like copies of this slide, the slides that were presented today, those will be added to the course player, as well as a copy of the recording as well. Just to let you know that that's all well and done there. And this does bring us pretty close to the end of our presentation. I do have a couple of minutes though, so I do want to see if we have questions here. So yes, the session is being recorded and you will be able to access the recording in our course player, as well as the slides. If you like the slides as well, you will be able to download the slides, be able to look at the slides, and then of course, once this course has been completed at 100%, you will be automatically enrolled into the exam course. And upon, I believe, something like 80% completion of that exam course, you will be able to get a certificate, which we'll send through email then you can actually use that to just verify that you are a technologist, an evangelist that is on top of cutting edge technology like distributed SQL. Okay, so just want to check the chat real quick to see if there's any other questions. Looks like we're pretty